math, numbers,
sine wave,
coordinates.
radius,
Let's factor. Let's factor more.
polynomials,
Numerator.
equations.
Close your eyes and step back into time, to the moment when you first learned addition. If you had 3 pennies and someone gave you 2 more, it was easy to count the result. Whether or not you had the real pennies, you could still visualize the answer. Now, as you've gone through mathematics year after year, it becomes less and less easy to grasp those concepts. And that is exactly what students struggle with most, is that abstract thought. What math teachers have done is create a tool that can be used to assist algebra students. This is the key to algebra, the key to our very existence. If you find that the lesson is moving too fast, please feel free to pause at any time. Let's start with an easy example. Let's look at 2 times 2. So back in elementary school, when you learned how to multiply, you learned to set this up with 2 on the top, 2 on the side, and then you found the solution by filling in the inside. So in essence, what we're doing is finding the area. And so then you count the squares on the inside, and it gives us the area. All right, another example here is 3 times 2. There's 6 on the inside. But what if we wanted to multiply by -3 instead of +3? So the algebra tiles actually have 2 different sides, the positive yellow and the negative, the red. So if we're multiplying by a negative, we're going to take everything on the inside and flip it over. And then if you multiply it by another negative, the same thing is going to happen. You're going to flip it back over to the positive side. So here we're looking at 2 different kinds of algebra tiles. The long ones are the x's. Okay, that's going to be our unknown variable that we don't know what that one represents. And then the little ones are the ones. So here we're looking at 4 times -x. And but now we're going to switch those over and flip them around to -4. And what we do as we flip over the side, we're also going to flip over the middle. So each of those negative x's goes back to becoming a positive x. And so this is a display of -x times -4. Your answer there is positive 4x bars, or in other words, positive 4x. All right, so what if we had 2 different expressions, both with variables in them? So that one expression there, x plus 1, has 2 terms, so we call that a binomial. When we multiply x times x, we get this giant blue box x squared. So here what we're looking at, we have the x squared, and then that 1 times x leaves us with the x. So as you can see, those are different shapes. They do not combine. Those are going to stay separate. Second example, this time we have 2 different binomials being multiplied together, x plus 1 and x plus 2. So I'm going to go ahead and set this up slowly. There's my x bar and 1, and along the side, another x bar, and I'm going to put 2 1s this time. And when I multiply the x times x, I'm going to fill it in with that giant square, the x squared. And the x times 1 is an x. I have the 2 times x, gives me 2 x's. And then lastly, the little edge of 2 times 1, which would be 2. So what's cool here is that we can see what combines. So this is where we see our combining like terms step. There are 3 x bars there. So even though we have x squared plus x plus 2x, those are really the same thing, those long green x bars. So there are 3 of them. That is all that combining like terms really is. And so we can simplify this expression, x squared plus 3x plus 2. Algebra tiles are nice because we can see the difference between x's, x squareds, and 1s. All right, this time we're throwing in a minus. Remember that x minus 1 is the same as x plus -1. So when we fill that in, we're going to use one of the negatives. Okay, and then here we're simplifying the answer again. So we have our x squared, we have 3 positive x's and 1 negative x. Now what happens when you put a positive and a negative together? they cancel each other out. And x's are no exception. A positive x and a negative x are going to cancel. So those we can move off to the side, and our final answer is that x squared plus 2x's plus negative 3. And then plus negative 3 is, of course, the same as minus 3, so we could rewrite that if we wanted to. Thank you for joining me on this mathematics journey. I hope that you learned something today. Please leave your comments for us. We'd love to hear them. And I will see you next class.